Hello, I have another piece of test gear by Agilent for repair. This time it is 66321B mobile communications DC source, which is a precision lab supply with some special features for testing battery-powered devices with spiky loads such as mobile phones. And the key features are fast transient response, precision current measurement, programmable output resistance to simulate internal resistance of a battery, and fast measurement of voltage and current waveforms with some special software. Almost 2 years ago I repaired a similar unit, which was 66309D, which had 2 channels. This unit has only 1 channel, 15 volts, 3 amps, with up to 5 amp peaks. I will put a link to that video below in the description. The unit has a calibration sticker here by Agilent in October 2010. As you can see, there are no connections on the front panel, only on the back. Let's have a look. Here is the back of the unit, and this is the output terminal block with jumpers installed between the output terminals and sense terminals. Let's see what's wrong with this unit. Nice and bright display, and the fan is quite loud, and here is some error. Now let's see what error is it. Error free. Any more errors? No. Let's see, it is set to 4 volts, 3 amps. Let's try enabling the output. It triggers some protection and the fan speeds up quite a bit. Now let's disable it and clear protection. Let's check if over voltage protection is set. It is set to 5.2 volts, which should be fine in this case, because the voltage is set to 4 volts. Let's try changing that to, let's say, 15 volts. No, still protection. Here I found error messages in the user manual, and the error free is non-volatile RAM cal section checksum failed. I wonder, is it related to the protection thing at all, or maybe these are 2 different problems? One of the bolts on the bottom of the unit is covered with Agilent calibration sticker. Let's see if I can carefully remove it. No worries. Here we are. I've seen similar supplies before. So, as I understand, this is the main control board. All power electronics is on the bottom board. And I don't think I've seen such a board before. I'm not sure what it is. Here is this board, and it has a D734 on it, which is high-speed analog multiplier. So it seems to me that this board has to do with fast measurements. So here I flip the control board aside Well, let's have a closer look. I don't see anything obviously wrong so far, and I don't see any battery for NVRAM, so I guess it must be a flash memory instead. In which case I really wonder, how did the checksum get corrupted? Perhaps the unit just needs calibration. Let's see if we can update the checksum just by entering the calibration mode and saving without calibrating anything. Let's try. Okay, let's go into calibration mode. Now we are supposed to enter the password, and I hope it is 0, which is default. Yeah, I believe we are in the calibration mode. So now let's go into the menu and look for the save option. Here it is. Let's try. How do we go out? Yeah, here it is. And now let's cycle the power. There you go, no error. Let's try enabling the output. No, there is still protection, so it must be some other problem, I suppose. I found in the user manual how to load the factory configuration parameters. Let's try. We need first to enter the calibration mode and then press both local and recall. And here we are, configuration menu. Here is the factory option, and let's select that. And now I think we need to save. And exit. Let's see now. Oh, no protection anymore. Great. So let's try to verify the performance. Alright, attach the meter to the output of the unit. And let's try setting, let's say 10 volts. Enable the output, and 10 volts just fine on the output, but the wrong reading on the meter here. Let's change the voltage to the limit, which is 15 volts. Again, the right voltage on the output, but the reading is off, so the reading needs calibration. So let's try to calibrate this. Let's disable the output, go to the calibration mode. Now we are supposed to go to voltage calibration and select the first calibration point, this one. And now we should enter this voltage into the power supply by doing this. Data, enter number 0.2717, and the last digit is not stable, so let's just enter this. Now we should go to the second calibration point. Oh, here I think we need to, select P2. And now enter this voltage. $14.89, and that's it. Now I think we are done, so let's save it. And get out of here. So now let's do this, and there you go, 15 volts. Yeah, no problem at all. Now let's give it some load. I run separate sense wires for accuracy purposes, so let's set voltage to 15 volts and the current, it is already set to the maximum. Fine. And let's set 3 amp load here, and let's enable this output and enable the load. It gives exactly 3 amps out, but again the current reading is wrong. We need to calibrate it as well. So let's try calibrating this. Let's disable the output, go to the calibration mode and select the current calibration. Here it is. Now we select the first calibration point and now enter the current, which is this 139, or rather 0.139. Enter. Now we select the second calibration point, and enter this. Uh, 2.0 9 6 6. Is jumping a bit or something. Not sure. I believe I see 73 sometimes. Okay, let's enter this. Now we should save it. And let's go out of the calibration mode and test. 15 volts, 3 amps. Not a problem at all. And I know this electronic load is quite accurate, but let's verify with the meter. I'm going to verify in the constant current mode just by shorting the output through the meter. Let's set the voltage to 15 volts and let's set the current to, let's say, 1 amp. And there you go. Quite accurate, not a problem at all. Let's set 2 amps. Yeah, I'm quite happy with the result. There is a separate step for 1 amp range current measurement. Let's calibrate that. We are supposed to select this measurement R3 and select the first calibration point. And now we should enter this current into the unit. Point 954 enter. And now one more step to calibrate the resistance. We need to set the electronic load to 2 amps, which I did. We are sensing the voltage on the back. And let's go to the calibration mode and select the resistance. Here it is. And now we need to go through 3 calibration points. Point 1, and we need to enter this voltage, which is very close. Uh, 2.9871. Enter. Now the second point. We need to enter this voltage, again very close. One 1.0342. And now we need to turn off the electronic load and go to the third point. And enter this voltage. which is again very close, so perhaps we didn't really need this calibration. .0119. Okay, we should be done, so let's save it. And get out of here. Here we are. I believe this thing is fully functional again. I wonder how did it lose the calibration parameters. I hope you enjoyed this troubleshooting and calibration. Thanks for watching. Bye.